We're going to take some close look at some of the functions that we have here on our graphs. So here on the left side of my notebook are simply functions. We don't necessarily deal with this kind of function on a regular basis, but what we're going to do is we're going to examine both domain and range. So when we're thinking about domain, we're thinking about how wide. So instead of looking directly on my x-axis, I'm just going to move my x-axis down here off of the graph, because my x-axis is nothing more than a ruler. So this here is now my new x-axis. So when I'm looking at the function, I want to say how far to the left does that function begin? Well, it begins right here where that open circle is. So my value right there is at where x is -2. I'm going to put an open circle because it comes really close to -2, but it doesn't actually equal -2. So notice that my stick is going to be vertical, because in order for me to tell the value of whatever is happening here for my x, I have to reference my x-axis. So notice that it's always touching my x-axis and is always touching the function, and we can assume, for the sake of this graph, that this goes on forever to the right. So that would indicate that my x values are everything this way and then go on forever. So my x is all numbers to the right, or I could say x is bigger than -2. So if I were going to write my domain, and I'm going to do it as set builder notation, I would write the set of x such that, well, I'm going to have to start with x. X is what? If I'm reading this way, x is greater, because it's on the big space side, so x is greater than -2. And I'm going to close my curly braces. Okay. So now if I'm going to put this in interval notation, my x starts at -2, not including, and it goes all the way out here forever, which I call positive infinity. So then that would mean that for interval notation, I would have, I'm going to start at -2, doesn't include it, that's why I have it as a parentheses, and it goes all the way forever to the right, which is positive infinity. So now I'm going to talk about range. My range I discover on my y-axis. So I'm going to draw my y-axis off the graph, off to the side. So my y-axis is here. So this is my y-axis. And I just want to know where is my y value. So it's only right here. That's the only place where that function touches my y-axis. So that's where y is 1, 2, 3. So that's where y equals 3. So my range is simply y equals 3. So if I'm going to write my range, and if I'm going to put it in set builder notation, which I'll abbreviate SB, I'm going to say it's a set of y such that y is 3. So if I'm going to put this in interval notation, I would say that my y is simply 3. So notice how this here is a bracket. This bracket means can equal. Okay. So let's go ahead and let's look at this one down here beneath it. These two are actually fairly similar with domain and range. A little different. So if I was going to go ahead and write my x-axis down here at the bottom, and I'm going to figure out where does that start. That starts right here at -2. This is a closed circle, so I'm going to put a closed circle. Means it includes it. So just like in the one above it, where I started here and it touches the function as I move to the right, the same thing happens with this function here. So that means all of these values of x can be inputted to draw my function, and I'm going to assume that this continues with an arrow. So this here is, again, positive infinity. So the only difference here is this inclusion. So that means here for my domain, in set builder, I'm going to say it's a set of x such that x is greater than or equal to -2. And for interval notation, which I'm going to abbreviate IN for interval notation, that means it's going to include -2 and go all the way to positive infinity. So this means it can equal, this means it comes close. And we can never get to infinity, so we always use that sort of parentheses. So now I have my y-axis, which I'm going to move off to the side. So this is actually going to be different than here. So I am going to realize that this is going down, and as it's going, it just keeps going somehow. It might level off a little bit, but it's going to keep going down. And it's going to keep going down forever. Just as it was going to the right forever, it's going down forever. So that means at the very, very bottom, it's going to be out here at somewhere at -infinity, because it's touching the function way off here. I just can't see it. I have to imagine off the graph. And it keeps touching this function until I get up here to this value of y is 2. That's where y equals 2. So if I'm looking at my values of y, it's everything from -2 down to -infinity. It goes down forever. So when I'm talking about my range, my set builder is going to be the set of y such that, well, what is y? Y is through here. Y is less than, because it's underneath. So y is going to be less than or equal to 2. If I write this in interval notation, my highest number is 2. It includes 2. And it goes all the way down to -infinity. Oops, I just made a mistake. This is backwards. Smallest number first. So let's go ahead and correct that. So I'm going to go from -infinity all the way to 2. Okay? It's just a matter of, we always write our smallest number on the left and our larger number on the right. Okay. So I'm going to ask that you try to do this last one here on your own and see what you come up with.